Hello everyone, welcome to compiler class. Today we are going to discuss about intermediate code generation and the implementation of three address code. Let me share my screen now. Okay. So intermediate code generation. So intermediate code generation is in a middle level language. So why does the compiler uses intermediate code generation is so directly, is it not possible for the compiler to directly convert it to the target code? Why is it converting to the intermediate code and then converting to the target code? It will be able to, but it is not always possible to generate such a machine code directly in one pass. So in one pass, we will not be able to directly generate to the code which we require it. For that purpose, what it is doing it is going to the intermediate code language, that is a partial conversion of your target code, and then it will be converting to the target code, which is the fourth phase of the compiler, which is not into the front end and not into the back end, which is in the middle of your front end and back end, wherein it will accept the input from the front end and it will give the output to the back end. This is how the intermediate code will be working. So let's just see how do we implement the intermediate code generation. There are three types of implementation of intermediate code generation. The one is syntax tree, postfix notation, and three address code. These are the types that we will be using intermediate code. But more often, most of the compiler, not most of the 99% of the compiler is using three address code only. It is not using syntax tree is also being used, but it is used in the second phase also. There's no point of using it again, but it will be able to find out the representation of how a three address code can be converted. So syntax tree, postfix notation, and three address code. So syntax tree, already we have discussed about syntax directed translation. So I've told you how do we construct a syntax tree. This is also a kind of a parser tree, but the difference is in parser tree, you will be constructing from the top till the bottom. That is, when you have given x is equal to a plus b, that you will be constructing from the top, then finally you'll evaluate the answer. But your syntax tree, it will be giving a operator precedence, like where the operator is being given higher precedence, that will be used. From the bottom, the tree will be drawn to the topmost. That is your syntax tree. Let me show you an example of it. See here, a plus b star c divided by a minus b star c. See how it has been drawn from here. B star c. This b star c is being taken because it is taken as an operator precedent. Then plus a, and that is being divided to b star c minus a, that both will be divided to form the x variable. This is how a syntax tree will be drawn, that we have also discussed how a syntax tree will be drawn in SDT itself. We have discussed about it. Please check into that video also. Okay, that is the representation of syntax tree. Postfix notation. Usually, the infix notation of an expression will be x is equal to, for an operator, if for example, my operator is a and b and I wanted to use the operator plus. My operand is a and b. So if it's in the infix book form, my operands will be a plus b. Operator plus b. That is my infix notation. If it's going to be postfix notation, the operator will be moved to the right side. That is, first preference will be given to the operand, then to the operator. That is the postfix notation. After postfix notation is more likely to be, it is what do you say, it is like linearization of a syntax tree is your postfix notation. Whatever that you have drawn in a syntax tree is a representation or an hierarchical structure of whatever that you require in the first phase, that you will draw it in an hierarchical structure that you will be representing in the syntax tree. Postfix notation, your syntax tree will be given out in the linearized form. That is your postfix notation. See, for example, for postfix notation that I've represented here, not this. See here, x is equal to a plus b. Here the postfix notation is ab plus. ab plus. Okay, or for this, how it will be taking? Here also not. This is an example for syntax. Really sorry. So this is how it will be taking it for postfix. For example, if I'm going to give an example of like x is equal to minus a star b plus minus a star b. So this is going to be my input string. X is equal to minus a star b plus minus a star b. How the postfix will be? Postfix. Oops. My postfix notation will be a minus b star. This minus has been moved to right. B star. Here it is plus. Leave off that. Because after that there is no operand. So again an operator minus. After minus we have an operand. So a minus b star plus then equal to. This is how it will be moving it from infix. It will be in the form of infix. Initially it was in the form of an infix that we will be converting. That is, it will be giving preference to the operator first, then the operand. Okay, this is how it will be converting infix to postfix. This is also a representation of a 3-address code, but this is not being used. Then the next one is in 3-address code. 3-address code example I've given here. So 3-address code, we will be using 3 operands and 1 operator, which is also called as an 3-address code. Even here I've mentioned, really sorry. Here also one postfix notation. Even here I've given a postfix notation example, a minus b star c plus d plus a minus d. Parenthesis will not be included in your postfix notations. Okay, so AB, leave off the parenthesis, AB minus, after star again open parenthesis, leave off that parenthesis. So CD plus AB minus plus AB minus plus this star. Okay, this is how the postfix notations will be considered. Then the next one is 3-address code. 3-address code will be having an 3 operand and 1 operator, or more than 3 operator, and then more than 3 operands will also be used in 3-address code. See, generally this is the reason it is called as an 3-address code. X is equal to y of z, that is x is an operand, y z is also an operand, operator, 1 operator plus minus or any operator that you will be using it. So this is how it is called. The no more than 3 references, that is 2 for operands and 1 for results, is known as a 3-address statement. Yes, so this is why it is called as an 2 operands and 1 will be stored as an results. That is the reason it is called as a 3-address code. Even if it is more than 3 operands, it has to be converted to the 3-address form. Then it has to be that code, you call it as an intermediate code generation. So this is the one that we will be using it in the compiler. Most of the time 3-address code will be used. So see here, my expression is going to be, I will enlarge it little bit because it's so small. Okay. So this is going to be my expression x is equal to minus a star b plus minus a star b that we have discussed for postfix also. The same example that I'm going to consider now. See here, my example for this will be, it is more than 3 operands, but I wanted in 3 address code. So I need to include a temporary variables, new temporary variables to form a 3 address code. Now you see T1 is equal to minus A, T2 is equal to, this minus A is in T1, T1 star B into multiplication of B, T3 is equal to minus A, T4 is equal to T3 star B, and T5 is equal to T2 plus T4. Correct? And X is equal to T5. This 3 address code, you can also able to optimize it. But now I'll show you how do you create it. If you want, you can optimize it. But I'll show you how do you create a tabulation for this. Okay, so excuse me. So the 3 address code will be represented in two forms. One is a quadruple, the other one is triples, and also indirect triples. So quadruple, triples, and indirect triples, more often we will be using quadruples only, not triples and indirect triples. We will not be using it most of the time, quadruples only, because that will be more but indirect triples will be very fast when compared to quadruples and triples, but the compiler will be using quadruples only. Let me show you that example also. With example, I'll show you so that you will understand more about it. See, quadruples. Each instructions in quadruples representation is divided into 4 fields. That is, one is for the operator, argument 1, argument 2, and results. This, for using it in the triples and indirect triples, I have mentioned it here itself to make it easy. But if you draw a tabulation from operator, arg1, arg2, and result, that's more than enough. So these are the things that operator, arg1, argument 2, and the results. These are the 4 fields that is required. So whatever that I have mentioned it here, same thing I can also, I should be using it in the tabulation. Okay. See here, your understanding, I'm keeping it. My T1 is equal to minus A. So what is my operator here? Unary minus. Minus is going to be in operator. U minus minus. My argument is only one argument A. What is the result of it? T1. And the next one, I'm giving it as number 0, 1, 2, 3. If you want, you can have it from quadruple. But triple and indirect triple only uses this. This is not required. So I'll just tell you what is it here. T2 is equal to T1 star B. So star is the operator here, star. First argument is T1. The second argument is B and my result is T2. Okay. And my third is T3 is equal to minus A. So minus operator, A is one operand. My result is T3. Okay. And what is my T4? My T4 is T3 star B. So star T3 B, my result is T4. And here plus T2 T4 T5. And here equal to X is going to be my result and the argument is T5. This is what is quadruple. Okay, this is how 4 fields are filled. But in triples, only 3 fields will be included. See here, operator arg1, arg2 has been included. But this is called as a reference. Okay, that is, instead of the temporary variables, it will neglect the temporary variables. It will have a results as, it will have the numbers as 0, 1, 2, 3, 4. Instead of T1, I'm putting this because my T1 is minus A, right? So 0, B. Okay, my zeroth line I'm multiplying with B. And here my second minus A. Here my second line is being multiplied with B. And here I'm adding first line, my first line. and my third line I'm adding it here in the fourth line. Okay, and in the fifth I am putting my fourth line values as a result for x. So x I'm giving an argument operator and 4 is a result. This is what I've created for triples. Indirect triples is instead of the 0, 1, 2, 3, 4, you will be giving an indirect, that is pointer to a pointer, that it will be considered as a pointer for a pointer. So for this 0, 1, 2, 3, again I'll have a reference. This itself is a reference to this. So again I'll have a reference like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. If I have it like that, so I can use it 0, 0. I will be using only that 0, 0, 2, 2, 1, 1, 3, 3, 4, 4 instead of 0, 1, 2, 3. This row will also be there. For this row, I will have a reference. Only that reference address I should be including in the triples. This is what about intermediate code generation. The intermediate code generation will be having, a representation of intermediate code generation will be syntax tree, postfix notations, and 3-address code. We will be using postfix notation and syntax tree in the second phase of the compiler itself, and the result of which will be used by the 3-address code. And in the 3-address code, in the intermediate code, and the intermediate code, the 3-address code implementation will be of two types, that is quadruples and triples, and indirect triples. It is of the form only two. In triples itself, we have another one which is indirect triples. Okay, so the 3-address code can be, most of the time only 3-address code will be implemented, that too a quadruple will be implemented, not the triple and indirect triple. This is all about your intermediate code generation. Furthermore, that we will discuss about generation of 3-address code, assignment statements, type conversion. This is also we'll discuss in the latest slides. Thank you so much for watching my video. Thank you so much for your time.